Good morning, everybody. Thank you for spending your Cyber Monday morning with me. My name is Ori, and I lead one of the solutions architecture teams for AWS. And that means that me and my team spend our time in the trenches trying to get different companies and device makers to integrate Alexa into their product. One of the sort of areas that we specialize in are products that have screens. And that means you need a very different kind of Alexa integration. So we spend a lot of time thinking about how do you have a good Alexa integration with a product that also has a visual component to it. So with that, I'm going to give you a little sneak preview of what you're going to be able to do if you integrate these visual components with an Alexa product. So let's just switch here. All right. And I will hit this. Perfect.
Alexa, what's the weather?
In San Francisco, it's 75 degrees with intervals of clouds. You can expect more of the same today with a high of 76 and a low of 45.
So I know that's a very deceptively short clip. It's only 12 seconds long, but a lot happened under the hood. For example, you saw that there was a voice chrome. The device was reacting to the person's speech, and then you saw that an actual display card came up that was context for the right skill that the person asked for. All right, let's switch devices. Perfect. So Alexa Voice Service, our goal is to get Alexa everywhere. And obviously that means that many devices are going to have a display. Displays are not going to go away. I know that people think of Alexa as a voice-only or a smart speaker, which I always love when people say that, sort of a modality. But the reality is that all you have to do is ask Alexa for a very long calendar entry or a very long to-do list, and you'll realize that people can read much faster than they can listen. So clearly we need a way to have visual responses for certain kinds of requests. So we're going to do a little bit of AWS 101. The important part here is that your device is going to capture audio. It's going to send it up as an event to the AWS cloud. That's where we do our speech recognition, our natural language processing. We figure out what the intent of the end user was, and then we package back a directive that we send to your device. And that's what your device will act on. Now, that directive is just a JSON payload. In fact, we also provide the AWS Device SDK. It's a C++ SDK, and it will even parse that JSON directive for you. So typically, when you make a request to Alexa, you're going to get that text-to-speech response that will say something like, now playing the Beatles from Spotify or whatever request the user made. But now you can also add visual metadata for that, and I will show you how to do that. So the first piece of magic is what we call display cards for Alexa. And this is where you add a different way of showing responses from Alexa. So what I'm showing here is just a selection. We have a much larger documentation of all the different sort of designs and templates that you can use online on the AWS Design Guide. But what I've done here is I've done a sample to show you. First, we have two different kinds of modalities. The smaller white templates are what we call the tablet modality. That's for a device that tends to have a smaller screen that's much closer to people. And in that case, when you make a response, you're going to take over the full screen. But we also have, as you can see, these larger, what we call side cards that are about a third of the width of the screen. And that's designed more for a 10-foot experience, like a television or a projector, where you don't want Alexa to be too disruptive to the background media that the person is consuming. And we'll show you different ways that you can use those templates for different kinds of requests. The one exception is on the right. You can see that we have what's a now playing card. And in that case, if someone's requesting a piece of media, such as music, It doesn't matter what kind of device type you have, we'll always do a full screen takeover because clearly if they want to consume media, it should take up the full screen. All right. So we're going to go back to our sort of AVS 101, how it works. You're going to send up your speech recognizer event as usual, where you package up the audio of what the end user said. And here's where the magic happens. You're going to get 2 responses now instead of 1. On top, you'll see the standard speech synthesizer directive, which is the text-to-speech response that you would get. But in addition, you're also going to get now the template runtime directive, which contains the visual metadata that you would want to display. Now, you're probably going to ask, okay, this is great, but today when I ask Alexa things, I don't get this visual info. Where is that hiding? I'm going to show you in the live demo, when you log into the AVS developer portal, there's actually just a little setting that you can turn on to say that your device has display capabilities. And as soon as you turn on that setting, you are going to get that template runtime directive to your device. One thing I would like to warn, though, is that because you're getting 2 responses to your device, what's tricky is that in the past, if you only had audio, you would just wait for that audio and then you would play it. Because you're now getting 2 different responses, you get a little bit of a race condition where you have to worry about, hey, I got my audio first and my visual later, what should I do? In many cases, it's okay. You should use 2 different threads on your device to take these different directives. That way, from a user experience point of view, you're still playing the audio right away if the visual information is just a little bit later. The one exception to that rule, though, once again, is the now playing for, say, music or other kinds of media. If someone is requesting a music track, you're going to have to block and wait for the visual information to come back, because it'd be weird to show people the wrong music information or no music information while a track is playing. But we'll get into that later. I'll show you where you can look at the audio item ID, and you can use that audio item ID to correlate the audio response with the visual response. All right, so now let's talk a little bit about the template runtime interface itself. It's a new interface that allows you to send back visual information to your device. The template runtime interface has 2 directives. The first is the render template directive. And the render template directive only has 4 different kinds of templates. Starting on the upper right, we have body template 1, which is your standard text response. Then we have body template 2, which is below that. That's where you see the text plus a picture. We also have the list template, which is on the lower left. This list template is actually very flexible. You can use it for all kinds of things. We use it for calendars, to-do lists, shopping lists, things like that. And then, of course, on the upper left, everyone's favorite, the weather template, which you all know and love. And then, of course, the only other directive is the render player info directive, and that provides the now playing card that you use for different things like books, music, and other kinds of media. And once again, it's going to be a full screen takeover. Now, these templates that I'm showing here, I selected from our design guide just a few, but we have lots of different kinds of looks for those templates. And that's because, your device, you're going to know your device and its screen way better than we do. So we have dark templates, light templates, templates for TVs, templates for more tablet-like devices. But at the end of the day, while we do send you this visual metadata, it is up to you to actually render that information on your device. Some devices have like a segment LCD. They'll have a different approach to taking out the text and display it on their display rather than just taking the templates that we have here. So now let's do a little bit of a deeper dive into one of the templates. This is the body 2 example. And what I wanted to show here is just how simple the JSON payload really is. So for example, you'll see that here in the image area, we're just containing the actual URL to the image. And that's what you would grab. We have both a large one and a small one, because obviously we're trying to cater to different sizes. But it's up to you when you render on your device which size image you're going to actually use to render. And you can see this just containing the actual text that you will display on your device. Once again, I showed a tablet example on top, and this is the more TV-like example on the bottom. But once again, you will be able to adjust these to suit your device. All right, so now let's do another quick demo.
Alexa, what's on my calendar?
Here are the next 5 events.
Alexa, play Smoke and Retribution by Flume.
Smoke and Retribution by Flume.
So what's important about that example is I wanted to show you what a TV-like experience looked like instead of the tablet experience that I showed at the beginning of the talk. And what's important there is when the user is speaking to Alexa, that you saw the voice Chrome pop up in that bottom right-hand corner. And if you think back to like an Echo device in your house, it has a blue LED light ring. And as you speak to it, that light ring actually gives real-time feedback to the customer so they understand where they are. So there are very basic states that you need to communicate, such as listening, that Alexa is actually listening to the customer speak. Then you have to show that Alexa is thinking, right? That you have to wait for the latency of sending that up to the cloud and coming back down. And then, of course, when the response comes back, then Alexa is speaking, right? And then you show that state when Alexa is speaking. And then there's other error states and things that you have to show depending on different contexts. But that's what the voice Chrome does. The other important point about the voice Chrome is we'll provide you those assets, but once again, you're going to have to put that locally on your device. And the reason for that, of course, is just real-time feedback. You want to have a really snappy response and user experience for people. It's not something that we could do from the cloud because that would be a little bit laggy. All right, so now we're going to do a little bit of a live demo. All right, so let's see if I can make this. So the first thing I wanted to show you was there's a cute little site called echosim.io, which you can just pull up in a browser. And if you log in with your Amazon credentials, you can actually play right there with AVS in your browser. And it has a console mode that you can turn on right here. The console mode is really nice because it will actually show you the JSON payloads and the directives. Unfortunately, due to the demo curse, I can't get this to actually work on the hotel Wi-Fi. So I can actually show you the cards here. But trust me, when you're not on the Wi-Fi here, you'll be able to just go to echosim.io and quickly start playing with the display cards without having to do, install it on an actual device. And as I promised before as well, here is where the magic happens. If you log into the AVS developer portal, you will see under capabilities for your device these different checkboxes. And at the bottom here is display cards, which you can then turn on, and that will start to send the actual visual metadata to your device so that you can experiment with it. And what would you experiment with? Well, I have loaded here on my computer the AVS Device SDK. It's a C++ SDK that you can download for free from GitHub. This is just the version that's up there. The latest version is 1.2. And what I'm going to do is I'm going to run it and show you an example of what it will do with visual metadata. What's the weather in Las Vegas?
Right now in Las Vegas, Nevada, it's 71 degrees with clear skies and sun. Today's forecast has intermittent clouds, with a high of 71 degrees and a low of 45 degrees.
So you'll notice right here that it actually says, yes, I see that there's a rendered template there. Here's the render template type. But it's not going to actually render it visually, right? That's up to your device to do. But you can see that that AVS Device SDK can now handle those payloads. All right. Back to HDMI1. So while it's great to have a device that shows visual responses to people, the next problem you're going to have is in order to even talk to Alexa, people have to sign into Alexa. And this can become a problem on several kinds of devices that have displays. Think of a smartwatch or a TV. First problem you have is the dreaded on-screen keyboard that we all hate. This is the one from Fire TV, so I'm just being fair even to our own devices. Onboarding is hard. Typing credentials is also really hard. So what we've done is we've developed a very simple solution for this problem. And that is basically a very OAuth-style authentication scheme. So what we do is on a device that has a display but not good input, we'll actually show you a code to the end user, and then they'll go to a second device, most likely a tablet or a mobile phone, and then they will use that to actually just log into Amazon and type in the code, and then the device will obtain the keys that it needs to then talk to Alexa. So I won't go too deep into all the steps that are required, but it's a very sort of OAuth 2 style request. The first thing that's going to happen is your device is going to talk to log in with Amazon, which is our authentication mechanism, and you're going to grab two things. You're going to make a post request, and you're going to get back the URL that the user is going to need to go to, and you're also going to grab the code that you need to display to that user. And then after you display those things to the user, your device is going to go into a loop, checking with the service to see whether or not they have been granted the access. Once that step is done, you're going to grab the tokens from AVS, and you're going to get two tokens. You're going to get the actual token to access and a refresh token, because every hour AVS expires the token, and you'll need to grab a refresh token. All right, so once you have gotten your customers onboarded onto the device and you're showing them visual information, what else can you do with this new sort of visual Alexa experience? So I'm going to talk about two cool sort of skill things that you can do with your device. The first is smart home for entertainment devices. So the best way to think about this is, obviously Alexa is very, very strong in smart home, and they've extended that to AV devices. So the mental framework that I like to use is all these devices come with remote control. Smart home for entertainment devices allows you to replace anything on a physical remote control with voice commands. So the perfect example, of course, is you could ask Alexa to change the HDMI input on your television. Or you could ask to turn up volume or change channels or anything like that. So that's what the smart home entertainment can do. Now, I'm not going to go into all of the different interfaces, but you can see that we provide now all these interfaces that allows you to essentially do most of the things that anyone would ever want to do with a remote control. But there's one other area that probably customers are even more interested in than just replacing their remote control, and that is, of course, being able to search for specific content. So we have another set of APIs called the Video Skills API. And the way to think about this is this allows people to search for any piece of content that they want. Right, today, people run into a problem that if they want to watch a particular show, they have to remember what streaming service is it on or what studio produces it. They would have to use a custom skill and say, Alexa, tell CBS to play show X. But with Video Skill API, we take all that away. The person can just walk into the room and say, Alexa, play X show, or play movies by X actor. And we, by ingesting your content catalog, are able to provide the right media or a search for that media without them having to think about a custom skill or having an awkward invocation phrase. Anyways, we have more sessions on all of these things here at reInvent, so I won't go into all the details about how to do content ingestion, but just know that these are the kinds of cool things that you can do when you have a video device connected to Alexa. All right. So now we've covered a lot of things. We've talked about display cards, voice Chrome, code-based linking, all these skills. So now I want to show you that it's not really that hard. We have Hisense. They're a smart TV manufacturer. They're one of the first people to actually integrate all the things that I just talked about into their smart TVs. And just a few days ago, I told them I was giving this presentation, and they actually went to their lab and did a little screen grab of of some of these things actually working on their TV. So bear with me, it's a little rough around the edges, but you can see that with just in a very short amount of time, people can integrate this into a device, and I wanted to show you what it looks like. So let's switch to this. All right, so there's no audio because this is just live off of a demo prototype unit. But the first thing that happens is they get the code request. Then they're going to go to Amazon and put in that code, and the device will obtain the tokens. Then they get the success screen, and once they have done that, they're going to actually make a couple of requests. The first request is going to be our lovely weather requests. So there's the voice Chrome coming up, and then you will see the card come in. Obviously, the UX has not been fully ironed out there. And then after this, they're going to make a music request, and you'll see the full screen display card come up. And so there you go. All right, so I know we covered a lot of stuff. The first, of course, is that you can dive much deeper into any of these topics up on our developer website. We talked about display cards and voice Chrome. Once again, these are open APIs that you can access. We talked about code-based linking, an easier way to get those people onto there. We talked about the design guide, which I highly recommend that you look at. We've worked out all the different processes for different kinds of devices and different looks and feels that you can then customize for your device. And then we talked about a couple of the skills that you can enable that have cool visual components to them that you can use for a visual device. Anyways, if you have any further questions, I'll be out in the hallway. You can come up and chat with me. Thank you so much for coming out today.